Modern sawmills choose LMI 3D vision sensors for their reliability in tough environments, speed, ease of use, technical documentation, and world-leading customer support. Gocators are built from the ground up with an all-in-one design philosophy, allowing sensors to be easily mounted and generating accurate raw data within 15 minutes of unboxing. In this video, we will walk through the full process of turning raw logs into boards of different sizes. This includes explaining what every LMI sensor in this particular sawmill does and how the laser technology plays a crucial role in optimizing wood recovery, making sawmills more profitable and sustainable. This sawmill is located in British Columbia, Canada, and mainly produces high-grade cedar products. The raw logs first need to be cut to a length that maximizes the usable lumber of each unique log. The logs are fed into the bucking line on hourglass feed rolls and positioned utilizing hydraulic stops at specific increments. A large circular saw then cuts the logs to length. The next stop is a step feeder, which singulates the logs and feeds them onto the conveyor, with a required gap for downstream processes. A large rotary debarker uses rotating tools to scrape and strip the bark off. It adjusts dynamically to a wide range of log sizes and shapes. Logs are then sent down a conveyor and sorted by size into different processing streams. After entering the mill, the large logs are sent to the head rig carriage, and smaller logs are sent to the chip and saw line. At the head rig carriage, optimization utilizes 9 LMI ChromaScan sensors to create a 3D scan of every log, analyze the 3D shape for features such as taper, sweep, and crook, and then determine the optimal way to divide the log into a cant and flitches. Each scanner projects multiple laser lines along the log length, allowing a full scan of the log to be captured with minimal log movement. Since the scanners are all linked together, their data is stitched to generate the full 3D scan. ChromaScan 2440s are specifically designed for the wood industry, calibrated and expertly crafted to provide reliable data in tough environments. After sawing, the resulting cants and flitches are separated into different conveyor streams. Let's look at the flitch scanner first. This machine center uses a series of Gocator 250 and 205 sensors above and below the conveyor to create a 3D scan of the flitch, which are boards that have a live or natural edge to them. These sensors not only generate 3D data of the flitch, but also detect knots and other defects using trachea detection as well as color vision. All of the data is quickly processed on-site, resulting in a customized decision to maximize the wood recovery of each flitch. Once that decision is made, they are sent to an automated robotic saw to be trimmed. Cants, on the other hand, are sent to a machine center that generates a complete 3D scan of each cant. This is achieved by mounting 4 LMI sensors in a ring layout at a breakpoint in the conveyor belt. The 3D data is quickly sent to be processed, where software determines the optimal way to turn every cant into a specific number of boards, depending on the shape of the cant. Boards that come from cants as well as flitches are then sent to the board scanner. This large conveyor system first segments the boards and then runs them through more laser scanners, this time ChromaScan 3155s, to calculate the best way to trim the boards to maximize the amount of usable wood. The boards are moved into position by a paddle fence and cut inside the trimmer enclosure, where multiple saws are mounted and activated to make the appropriate cut. The sensors at this station also check the quality of the boards, including wane, thickness, and width. After being cut, the boards are then sorted into bins by size. For packaging, a machine is used to stack boards together, where they are removed from the factory and set up to dry. After drying and grading, the finished product is then packed, wrapped, and placed on a truck to be delivered to buyers. All of the byproducts, such as bark, sawdust, and chips that were not able to be turned into usable lumber, are gathered and sent to different processing facilities to be fully utilized for other products like landscaping materials. LMI has been involved in the wood industry for decades and is continuing to push the boundaries of what is technically possible in order to maximize uptime and profits for wood processing companies. LMI's passionate, dedicated, and reliable customer support team continues to make a positive impact for system integrators all over the world. For more information on how LMI technology is utilized in the wood industry, click on the link in the video description. And if you would like to speak with a professional about your application, reach out to us at lmi3d.com.